we'll go on and start today's lesson. Today we are talking about kites. So we talked about trapezoids yesterday, and today we're talking about kites. A kite is a quadrilateral, four-sided figure that has two pairs of consecutive congruent sides. Two pairs of consecutive congruent sides. But opposite sides are not congruent. So this one is not a parallelogram. Consecutive congruent sides, so the sides that are next to each other, two are going to be congruent, and we'll have two of them. So these two sets of sides are congruent, and these two sets of sides are congruent. We'll have two sets of congruent sides, and the sides opposite each other are not going to be congruent. So we look at this here. This here is a kite, for which values of x is each figure a kite. Now we're told what? That GT is 17 and TO is 21. So are those two sides congruent? No. So these two are different lengths. So what would be congruent to GT? And 6x minus 3 would be congruent to TO because we have two sets of congruent sides. Because if this is a kite, we're going to have two sets of congruent sides. The sides that are next to each other will be congruent. So if I want to know what the value of x that'll make these congruent is, well, what? I can set 4x plus 1 equal to what? Not 180, but 17. Because those two are going to be congruent. Those lengths are going to be congruent. We also know that what? 6x minus 3 is going to equal 21. Does it matter which one I solve for? Or which one of these equations I solve? No, because the value of x should be the same. So if I solve this here, 4x plus 1, well, the first thing we need to do is subtract 1 from both sides. Because negative 1 plus 1 would give me 0. Leaving me with just 4x is equal to 17 minus 1 is 16. And then from here we can divide both sides by 4, telling me what? X is equal to 4. So what do I expect x to be on this other equation? 4. And we can do it here and check. So the first thing we can do is add 3 to both sides. Negative 3 plus 3 will cancel, telling me that 6x is equal to 24. Then we would divide by 6. Then we get what? X is equal to. So the value of x that would make this be a kite is 4. We have two. The consecutive sides of a kite are congruent. And the opposite sides are not. Okay. And that's it for that problem. I'm going to have to fix the notes. I thought they had those printed down and filled in for you, but they don't. Now, the first one, the kite diagonal theorem, 7.18. If a quadrilateral is a kite, then its diagonals are perpendicular. If it is a kite, then the diagonals are perpendicular. It means the diagonals intersect at what kind of angles? 90. They'll be right angles, because perpendicular means they intersect at right angles. So the diagonals of a kite are perpendicular. They form right angles. If a kite is a quadrilateral, if a quadrilateral is a kite, not the other way around, then exactly one pair of opposite angles are congruent. If it is a kite, then one pair of opposite angles are congruent. Now, it's a specific pair of angles. The angles that are going to be congruent are the ones that are between the non-congruent sides. In a kite, the angles that are congruent are the ones between the non-congruent sides. Those are going to be congruent. The other two will not. The angles between the congruent sides are not congruent to each other. But the angles between the non-congruent sides are congruent. Any questions on any of this here so far? Hold on. All right, that's easier. So this is the figure here. And we're going to start solving for some angles. We might deal with some of this side lengths, but we're going to start solving. So for what value of x is each figure a kite? Well, we know it's a kite because it has what? Two sets of congruent sides, two sets of consecutive congruent sides. We have two sets of sides that are congruent, and they are next to each other. So what do we know about the angles of the diagonals, these lines here? These angles here are 90 degrees, yes? So I know that what? 6x plus 6 is what? 90 degrees. So to make this true, we can set 6x plus 6 equal to 90 and solve for the value of x. So what can we do first? We can minus 6 from both sides. And when we minus 6 from both sides, well, these will cancel, leaving me with 6x is equal to 84. And then we would divide by 6. 6 divided by 6 is 1, leaving us with just x. And 84 divided by 6 would be? So the value of x for this here would be 14. And that's all we have to do for this here. Let me multi-jet. Find the measure of angle D in the kite shown. Find the measure of angle D in the kite shown. So we know it's a kite because we have two sets of consecutive congruent sides. We know that one angle is 115 degrees, and one angle is 73 degrees. What do we know about the other two angles? What do we know about angle D and angle F? They're congruent, yes. The measure of angle D is going to equal the measure of angle F. The angles between the non-congruent sides are congruent. So angle D and angle F are between the non-congruent sides, so they would be congruent to each other. So how can we go about solving for these two angles here, or one of these angles? Add it to what? X and what else? Is equal to? Because again, this is still what? A quadrilateral, it's still a four-sided figure. The sum of the interior angles of a four-sided figure is 360. Now we can just solve for the value of x. So if I can combine my like terms, well, x plus x is 2x plus. So 73 and 115 would be 188. And our next step would be 2. Bring it to minus 188 from 360. Those would cancel, leaving me with 172. And last but not least, we would divide both sides by 2, telling me x is equal to 86. Any questions on this here? Any questions on anything we've done so far? If we're good with this here, let's look at this one here. Would we do something different for this one here? No, this is going to be the exact same thing. We know that all 4 angles add together to be 360. So I can add 48 plus 101 plus x equals 360. And the reason we can do this is that because angle 1 and angle 2 are congruent. X plus x will give me 2x. 48 plus 101 is going to be 149. And again, like we just did, the first thing we can do is subtract 149 from both sides. But again, we're trying to get the value of x by itself, so the first thing we need to do is get x by itself. And subtracting 149 from both sides will give us 2x is equal to 1, 1. Yep. And that's fine. Because even though this doesn't divide evenly, we'll have to divide it by 2, which will give us so the measure of angle 1 and 2 is both 105.5. So if this were on a test, we would specify angle 1 is 105.5 degrees, and the measure of angle 2 is 105.5 degrees. They're going to be the same. Because there's nothing really restricting us from having an angle with a decimal. That's perfectly fine. Yes, sir. Yes, ma'am. Yes. Any questions on this here? Are you good with this here? Yes. No. Because for this one here, we would what? Add those 4 angles together and set it equal to 360, yes. Because the sum of the 4 interior angles of a kite is 360. And solve for the value of each angle.
Since it's like kind of like a triangle, like the top, we do it that way.
Draw a line through 1 and 2. Kind of like this here. We could, and actually that brings up a good point. Because if we look at this here, the angle, let's see if I can grab it. Okay. This is drawing. This angle here and this angle here, where that line, that diagonal is formed, are going to be congruent. They're going to be congruent to each other. Let's get a different color. And this angle over here and this angle over here would be congruent to each other. And I'll call this 1, 2, 3, and 4. Now with this here, 1 and 2 would be congruent. 3 and 4 would be congruent. But would 1 and 3, or 2 and 4, would they be congruent to each other? Well, no. Now 1 plus 3 and 2 plus 4, the sum of those angles would be congruent. And each of the parts, the angles on either side of that line would be congruent. But the 4 wouldn't be congruent to each other. Now for this problem here, it wouldn't make it any easier because we would have to solve this as 1 plus 2 plus 80 is equal to 180, and 3 plus 4 plus 44 degrees equals 180. So I'd have to solve for the measure of each of those sets of angles and then add those measures together to find out what those two angles are. So for this one here, it doesn't make it any easier. And I feel like we've got a good handle on this here. Yes? So we're going to move on to this one here. Yes. And for those of you who did that last problem that we saw, it should be 114. Okay. Now, as we look at this one here, they put the two diagonals in here. They put the two diagonals in place. And when we look at this here, now we can start kind of using triangles, because here, angle 1 is right here. And what do we know about the measure of angle 1? Yes. 118? Let's see here. Okay. So looking at this here, now 1 is in that corner where those two diagonals intersect. So what's the measure of angle 1 going to be? 90 degrees. The measure of angle 1 is equal to 90. We still need to find the measure of angle 2 and the measure of angle 3. So we're missing these two here, yes? Well, actually, what we talked about a minute ago is going to be a little bit helpful, yes? Because what do we know about 2 and 3? They're going to be the same, yes? Well, it kind of made sense. Well, I talked about it a little bit ago, yes? And there's a reason for it. Because if we look at this here, I'm going to kind of trace it in blue. This here is a triangle, yes? What do we know about the two sides of the triangle? They are, and the angles, which would make it isosceles, yes? And the angles opposite the congruent sides are congruent. So that means angle 2 and angle 3 have to be congruent to each other. So that means whatever the measure of angle 2 is, it's going to be the same for the measure of angle 3. Yes? Now in this top one, I know that this here is a right angle. So the measure of angle 2, I have a 90 degrees and I have 27 degrees, yes? So what can I do to solve for the angle 2? I mean, yes, I mean, we can subtract 180 from 90, and it would really be what? 27 plus x And that was our right triangle theorem. In a right triangle, the sum of the two acute angles is 90. So we can do it either way. If we add 90 and 27, we'll get 117 equals 180. And from here, to get x by itself, we need to subtract 117 from both sides. And if we subtract 117 from both sides, we get x by itself. And it's equal to so our missing angle in this triangle is 63 degrees. And that's it. So we know that the measure of angle 2 is 63 degrees. We also know that the measure of angle 3 is going to be what? Because those two angles are going to be congruent. Now, what do I know about the measure of this angle here? What would it be? It would be 27. Any questions on this here? Are we good with this here? Awesome. All right. This one here is only asking for two angles, the measure of angle 1 and the measure of angle 2. Is there one of those angles that we can find without calculating anything? What is it? 90. Because again, the diagonals are perpendicular to each other, so they form right angles. That's kind of nice, isn't it? That should be an easy one to get, yes? The fact that all the angles in a kite where the two diagonals cross is going to be 90 degrees. Should be a nice one, especially if it shows up on the test. It will show up on the test. Yes. Oh.
But like, whenever they mean a kite, do they like shape it as a kite? Is that what it's called?
That's a good question. And most likely it's going to be that way because most kites, if we have two sets of congruent sides set up that way, it's going to form this kind of overall shape. If the sides are if the two sets of sides, one set is way smaller than the other, it will form that shape. Now, if they're a little bit bigger or closer to each other, it won't be as kite-ish in shape. Now, don't ask me how they actually fly, because I don't know the mathematics behind that. Okay. But if I get a whim, I might look it up and see. Now, if we want to find the measure of angle 2, well, we know this is a right triangle, yes? So we know those three angles add together to be 180. So we could say that the measure of angle 2 plus 65 is 90 because of our right triangle theorem, or because the acute angles of a right triangle do add together to be 90. Because we could do it this way, or we can say x plus 65 plus 90 is equal to 180. Both of these will give us the same answer. Now, if we look at the one on the left, well, to get x by itself, I would subtract 65 degrees from both sides. 65 minus 65 would cancel, telling me that x is equal to 25 degrees. If we did it the other way, well, 95 plus 65 is going to be 155. And here, if we subtract 155 from 180, we get that x is equal to, well, 25 degrees still. They will be the same. Any questions on this here? Now this time we're trying to find three angle measures. Measure of angle 1, the measure of angle 2, and the measure of angle 3. Are there any of these here that we know from just looking at this figure? Okay, what's the measure of angle 1? The measure of angle 1 is 90 degrees because, again, those two lines, the two diagonals, are perpendicular. Now, we know that angle 2 is 51 degrees because it works out that this angle right here and this angle right here are going to be congruent. They're going to be congruent. So that leaves us with finding the measure of angle 3. Well, if I want to find the measure of angle 3, what can we do? We can call the measure of angle 3 x. So we'd have x plus what? Is equal to 180. Now the first step in solving is to combine our like terms, so 51 plus 90, which is going to be 141. And from here we can subtract 141 from both sides. 141 minus 141 is 0. We get x is equal to what? 39. Yes? Another way to calculate this, and this is part of the way I do, especially with y'all's grades, test grades, you will have a test next week, is if I'm trying to do the subtraction here, one way we can do it is we can start with 141. So I look at the 1. Well, if I add 9 to it, it goes from 141, this makes 10, and I get what, 150? What do I need to do to 5 to get to 8? 3, yes? And now we have it. And that's it. So that leads us to this. And this is the last slide, isn't it? Kites. Kites are defined by having two sets of consecutive congruent sides, and the diagonals are perpendicular. That means the diagonals form right angles. We also know that the angles between the non-congruent sides are congruent. And we can also really say that these are congruent and these are congruent here. Yes? Okay. These are, yes. We still have time. Awesome. Okay. I'm going to name these angles 1, 2, 3, and 4 where that diagonal cuts them, yes? Is there anything we could say about angles 1 and 2 and 3 and 4? They are. I mean, it's nice if someone says that, but it would be more helpful if it's actually true, right? Well, let's look at it. Well, in this triangle, these two triangles, because I just split it in half, yes, with that line, the diagonal kind of split it into two triangles. Well, I could say KS is congruent to KS, yes? I mean, the line's congruent to itself in both triangles. Well, we have that JK is congruent to KL. Well, yeah, the top two lines are congruent to each other. I also know that JM is congruent to LM. Yes? What do I have? I have a set of sides, and a set of sides. Yes? Well, if I have 3 sets of congruent sides, it means the 2 triangles must be congruent. Yes? Well, I can use this. Do you all remember what the 5-letter acronym is? Or, because I still do that too. It's not first word is not congruent. It's corresponding parts of the corresponding parts of congruent triangles are congruent. Well, what are corresponding? 1 and 2 and 4. It works out. But it also means that angle J and angle L are congruent. Well, we knew that already because it's a kite, yes? The angles between the non-congruent sides are congruent. Now, we can't say that 1 and 2, this whole angle here and this whole angle here are congruent because they're not, because they can be different. But it works out that the diagonal bisects it. The diagonal will bisect the non-congruent angles. The diagonal will bisect the non-congruent angles, but it will not bisect the congruent angles.